Hello guys, welcome back to another eBPF programming series. In this part 8 of this programming entire series, and actually it's part 4 of network security. In this part 4, we will be discussing more about honeypot, what a honeypot is, how we can develop a honeypot using eBPF and XDP stack. And if you don't know what a honeypot is, it's a tech stack that we deploy to catch hackers or for research purposes, to identify how hackers attack and what they do after attacking the honeypot implementation. And there are different types of honeypots, and its usages are different. Like we can deploy it for research purposes, or we can deploy in corporate environment as a last layer of security. So normally in a corporate environment, if a honeypot is generating some alert, means some serious incident happened inside the network. Otherwise, we can deploy it for research purposes, like on public facing IPs, to collect the data for threat purposes, to get the IPs, and if the attacker tries to interact with that honeypot, then it could be used for post-exploitation activities, to learn about the post-exploitation activities. But there is another part, is called non-interactive honeypot. This is the one that we are going to develop today. This one is simply just a honeypot that simulates something that doesn't exist. Or you can create non-interactive honeypot in different ways. You can actually create the real environment. Like you can, instead of simulating the ports open scenario, you can purposefully open ports on non-interactive honeypot, but it doesn't allow to interact with the honeypot. As an example, when we say when the attacker tries to scan port 21 in one of the honeypots that you deployed, in a non-interactive honeypot, it just sends back make a feel to the attacker that the port is open, but it will never allow you to interact with the honeypot try to connect to the honeypot using FTP. Suppose if the attacker tries to do some brute force, any other stuff on the non-interactive honeypot, it doesn't allow any kind of activities because it just simulates the port. That being said, you can either completely open the port on your honeypot and doesn't allow it to interact, or you can completely simulate the port open scenario. That's what we are going to do today. And how it can be achieved using eBPF is like there are different ways. This is one of the ways that you can achieve. We'll be simulating port open scenario using XDP. I don't know whether you have seen my previous videos. In one of the XDP series, the first one, when I introduced XDP, we developed an ingress firewall. There I mentioned the possibility of packet manipulation using XDP, and here we are doing the same thing. We are manipulating the packets, and we are sending back the data to the attacker itself by making a field to the attacker that a port is opened on the target machine, but there is no actual port is opened. That's what we do using this XDP and eBPF today. So in this honeypot, actually I'm not logging anything because it's just a demo of how we can achieve the functionality. Later, I'm planning to implement more functions to this, like logging mechanism. It captures the IP of the attacker that could be used for threat intelligence, so I can log it somewhere. I can send to some useful area where it can save the data for future purposes. So that's what about the theories. Let us have a look into the actual implementation. And this is going to be my attacker machine, where I'm going to try to scan from this machine to the target. And this is my target machine. and this is the source code of this actual eBPF hook. And I'm not going to talk about XDP in detail, but if you're hearing this first time, XDP allows you to process packet even before it reaches a kernel. So there is no actual kernel socket buffer is not created for these packets. You can process the packets and you can decide on what could be done inside that packet. So what we do here is we are manipulating the packet. If you have seen my previous video, as I mentioned, there we were doing an ingress filtering where we block the data, like after checking based on some IP and port, we block the data, we drop the packet, so it didn't reach the kernel and it was completely like an ingress firewall. Here we will be manipulating the packet. The same set of logic that we use here. The main thing here is we are checking. I'm just simulating 2 ports here, and if the destination port is mentioned as 21 or 22 from the attacker machine, we check whether it's an initialization of the first packet and ensuring that no ACK flag is set. I hope you know the 3-way handshaking rules. And the main thing happens here, we swap the MAC address. We change the source and destination MAC address here itself and change the source and destination IP. So effectively we are manipulating the packet by we are making it ready to send back to the attacker itself. So while we are making it, we have to swap the MAC address, IP and the ports. So this is ready for after doing this one. This is the main thing you have to do. We have to set the flags like a normal communication. As I said, you should be familiar with this 3-way handshaking. Here we are sending it back to the attacker after manipulating all the swapping all the IP MAC address and ports. We are setting the flags for our packet. We are making it ACK as 1 and SYN as 1. So as per the rule, for the response of initial SYN, normally the target machine has to send a SYN ACK back to the attacker or the scanning machine or probing machine. So once we set that, this is another part. Actually, this one for a scanner perspective, when I was analyzing using Wireshark for the Nmap scan, it doesn't matter for the scanners. Scanners normally omit this verification of checksums because it just scans it. But here I'm just resetting the TCP part of the header because we change the data here. We change the flags and other parts. So after making the change, I'm just using BPF some different diff function to change to set the new checksum for this packet that we modified in the TCP header. So basically this BPF some diff function is it calculates checksum differences, and it is useful when we are modifying the packets. After modifying, when we set the checksum, if you want, either you can do it yourself from the scratch. You can check the RFC for that and you can do it from the scratch. And why we use this function is because it's an part of eBPF, and this will be very useful when we are manipulating packets inside eBPF programs. And I tried this one actually without this one. As I said, normally scanners like Nmap doesn't calculate these checksums. That's what I see when I was checking this one. I saw that it didn't check the checksums for any of this, but I just set it on the TCP level because completely we are manipulating here on the TCP layer. But definitely it will affect the entire packet headers after the TCP. Definitely the checksum of the IP header must be set in a normal scenario. I tested with and without checking this one, and in both scenario it worked. And here is the most important part. After manipulating the packet, we have to use XDP TX. And if you remember on my previous programs and till here, all the checks were either it was XDP pass or XDP drop. On the ingress firewall, we were using XDP drop, and here we are using XDP TX. This will place the packet back to the same interface from where it came. Normally this is used in real-time scenario. I think load balancers, they use this one to perfectly load the network packets, but in this scenario we are using it for placing it back to the same interface. Actually in there also they are doing the same thing, but they are not manipulating these entire stuffs. I think they manipulate the IP headers and MAC addresses might be to place it back to the interface. So when we place it back to the interface, so the new packet has the destination MAC as the source MAC where it came from, and the port is same as like it will be the same destination port will be the same of the source port of the initial packet that came to the system. So after this, we are placing it back to the interface. And so what happens is when somebody try to scan it, even though there is no ports open this machine, it simulates a kind of what it does is like when we are sending a SYN-ACK back to the scanner assumes that there's the port of the target is opened. That's how the scanners works. So that's it about this program. And for the loader, yeah, as usual, the same loader, but here as I said, I'm not using any kind of logging mechanism, so I just copied my previous loader and commented out this mapping area. I'm not using any maps, but yeah, definitely in future version I'm planning to add this one and planning to replace my loader application using Cilium framework, so I can send my data to some. I can save my logging. I can save the so the attacking IPs and other information to somewhere. That will be easier for me rather than implementing using C. So that's my future plan of implementation. And remaining everything you are familiar with loading, how we can load it, and this is a way to attach. This is a way to get a reference from the skeleton. And this is the main function. It helps us to attach this XDP to the interface. So that's it about the source code. Now if you look at let me show the demo of this one, and before that I'm just see there's no port open in this one. Let us go to our attacker machine and try to scan it. And this is my target machine, actually 163, and let me simply see there is no port opened. And come here, let us build this one, make eBPF, make a skeleton file, make a manual loader. Now we have the eBPF object, and I made a skeleton from the object, and I'm using the skeleton inside my loader. So the next thing is I just need to load this. So it just simply prints this, and internally it loaded. Actually, it loaded to my interface. So again, come here, just check it, just to ensure that there is no actual programs running on the port. So again, we come here on the target attacker machine. We try to scan this. See, now the previous result was port closed, and now it is port open. Oh, sorry. Let me capture the packet. Once again, I try this. As you can see, we are sending a SYN packet, and we are getting a packet that is SYN and ACK SYN and ACK flag is set from our target. So the scanner assumes that the port is opened on the target, but we don't have any port opened on the target machine. Actually I have made 2 ports opened. I mean, it's not opened, but similar to 2 ports. So even if you try with the 22, it will be same. See, port 22 is opened, and it internally it assumes that service is FTP and SSH, because that's how Nmap is designed. And you can see the same process here. I can see the return packets has SYN and ACK enabled here and here. From the target to the source, SYN ACK enabled. So it is assuming that the packet is, I mean, the port is opened on the target machine. So that was about this video I planned. Where is it? Yeah. And the some new things I learned is, especially, yeah, of course, something, this function, you just try what exactly it is. There's a difference between N2HS and N2HL. Just try what it is, learn from that, their documentation, and this is the main thing I learned. And yeah, of course, the first time I'm trying packet manipulation in using XDP. So that's all about it. The next version of this one, but one thing I failed was I couldn't set a banner for this one from here, because setting a banner to the TCP payload didn't work for this using XDP, because XDP is not designed for that mainly. It's a kind of stateless technology stack that doesn't allow to keep any states. That's what I think. So packet manipulation is up to this level will be working. Maybe if your banner is shorter, that maybe, I don't know, I'm not sure about that. When I tried that one, it didn't work. It didn't make any error, but it didn't work for me. It was not sending the actual banner that I was setting using here. So what I'm planning is, I'm going to extend this application using TC filter. So I will get the full buffer, the kernel buffer for this packet. So I will get, I have more options to manipulate it completely. So definitely I can play with that more. And so in that honeypot implementation, maybe I can achieve more, including the banners and adding more features to this. That will be going to be the next video for this series. And regarding the honeypot stuff using XDP, I think I have covered almost everything that I planned for. Yeah, this one, yeah, this is not, yeah. This one here, the benefit, main benefit is like we are not opening any port on the target, so it's just non-interactive one. We are just the XDP, and the benefit of XDP is not even, the packet is not even touching the kernel. We are manipulating and sending it back to the attacker from the NIC level itself. So it's more efficient and more faster. But yeah, less functions. We can't do all the operations on the packets like other TC filters, because TC filter will have more data when we are manipulating the packets. So that's it for this video. And if you like the video and if you like eBPF series, stay tuned for future videos.